Welcome to Part 8 of Applied Chemistry. In this section, we will explore power alcohol, a renewable fuel source, and the analysis of flue gases using Orsat's apparatus. This discussion will cover how ethanol is used as a biofuel and the significance of flue gas analysis in assessing combustion efficiency. Power alcohol refers to ethanol, C2H5OH, which is used as a fuel additive or a substitute for gasoline in internal combustion engines. As a biofuel, ethanol plays a crucial role in reducing reliance on fossil fuels and lowering greenhouse gas emissions. Let's take a closer look at its composition and source. Ethanol, the main component of power alcohol, is commonly produced by the fermentation of sugars and starches from renewable biomass sources like sugarcane, corn, wheat, and other agricultural products. While ethanol can also be produced synthetically from ethylene, most fuel ethanol comes from biomass, making it a renewable energy source. Ethanol is often blended with gasoline to form different fuel mixtures. The most common blends are E10, contains 10% ethanol and 90% gasoline. E85 contains 85% ethanol and 15% gasoline, typically used in flex fuel vehicles. These blends help reduce greenhouse gas emissions and improve fuel performance. Power alcohol offers several advantages. Renewable energy source. Derived from renewable resources, ethanol is a sustainable alternative to petroleum fuels. Reduced greenhouse gas emissions. Ethanol burns cleaner than gasoline, resulting in lower CO2 emissions and a smaller carbon footprint. Improved engine performance. Ethanol has a high octane number, around 108, which enhances the anti-knock properties of gasoline, improving engine performance in high-compression engines. Energy independence. Ethanol use reduces reliance on imported petroleum, enhancing energy security for many countries. However, power alcohol has some disadvantages. Lower energy density. Ethanol has less energy per unit volume compared to gasoline, leading to reduced fuel efficiency. Absorbs water. Ethanol is hygroscopic, meaning it absorbs water, which can cause fuel system corrosion and phase separation in vehicles not designed for ethanol use. Land use and food versus fuel debate. Large-scale production of ethanol from crops like corn and sugarcane can lead to competition for agricultural land, raising concerns about diverting resources from food production. Orsat's apparatus is a laboratory device used to analyze the composition of flue gases, particularly to measure the percentage of carbon dioxide, oxygen, and carbon monoxide. This is important in industries and power plants to monitor the efficiency of fuel combustion and ensure environmental compliance. Flue gases are the byproducts emitted from the combustion of fuel in boilers, furnaces, or internal combustion engines. The primary components of flue gases are carbon dioxide, oxygen, carbon monoxide, and nitrogen, along with trace pollutants like sulfur dioxide and nitrogen oxides. Analyzing these gases helps assess combustion efficiency and environmental impact. Orsat's apparatus consists of the following components: a gas burette for collecting and measuring gas samples, pipettes containing absorbing reagents, such as potassium hydroxide, KOH, for absorbing CO2, alkaline pyrogalol for absorbing O2, ammoniacal cuprous chloride for absorbing CO, a three-way stopcock for controlling gas flow during the analysis. The analysis involves the following steps. Sample collection. A sample of flue gas is drawn into the gas burette and the volume is recorded. CO2 absorption. The gas is passed through potassium hydroxide, which absorbs CO2. The decrease in volume represents the percentage of CO2 in the flue gas. O2 absorption. The remaining gas is passed through alkaline pyrogalol to absorb oxygen, and the volume decrease indicates the O2 percentage. CO absorption. Finally, the gas is passed through ammoniacal cuprous chloride, which absorbs CO, allowing the CO percentage to be determined. Result calculation. The initial and final volumes of gas after each absorption step are used to calculate the percentages of CO2, O2, and CO in the flue gas sample. Flue gas analysis provides crucial insights for monitoring combustion efficiency. A high percentage of CO2 indicates complete combustion, while high CO levels suggest incomplete combustion, which is wasteful and polluting. Optimizing fuel usage. By measuring oxygen levels, engineers can optimize the air-to-fuel ratio, ensuring efficient combustion without excessive air, which would reduce efficiency. Environmental control. Flue gas analysis helps reduce emissions of harmful gases like CO and NOx, enabling industries to meet environmental regulations. In summary, power alcohol, ethanol, is a renewable biofuel that, when blended with gasoline, helps reduce greenhouse gas emissions and improve engine performance. However, it also presents challenges, such as lower energy density and the food versus fuel debate. On the other hand, ORSAT's apparatus is a valuable tool for analyzing the composition of flue gases, providing important data to improve combustion efficiency and reduce environmental pollutants. We've reached the end of our detailed exploration and covered different topics in this video. Thank you for watching, and don't forget to like and subscribe for more tutorials on applied chemistry and other exciting topics.